Hi, this is Sarah Broninger. I'm doing a video on dividing of fractions, and I'm not making a video on how you flip and multiply because that's easily enough taught. I'm doing a video on the hard part. I'm doing a video on what does it mean when you divide by fractions and how do you demonstrate that to a student. And I'm doing this video at the speed at which I would explain it to another tutor, not the speed at which I would explain it to a student. And I'll give you one or two examples, but for a student, I would do 20 examples, and I would do them of varying difficulties. So I hope this video helps in nailing down the concepts of division and how they apply to word problems. Division can be thought of in two ways. We're all familiar with the way that I call split. It's the way you're first taught division in third grade. You've got 12 things, you split it up into 4 groups, and there's going to be 3 in each group. Is that cool? So here I've got 12 candies and 4 kids. I split the candy and each kid gets 3. Or you can think of it as fit. I have 12 things and I want to see how many times 4 things fits in. It will fit in 3 times. That's a different way of thinking about the math. So here I've got 12 pills and you take 4 pills each day. So how many days before you run out of pills? 3 days. Here your answer is an idea. You get an answer that is an idea of how many times something fits into something else. Almost all division of fraction problems are going to be fit problems. So we have to first make sure the student understands that fit is a way of looking at division. Okay. The biggest question in a division of fraction problems is, will it fit? So let's look at this problem. I've got 3/4, and I want to see if it fits into 1/3. Does it fit? So I take this and I just put it right over top. No, it doesn't. Does not fit. That's your very first thing. No, doesn't fit. Here I've got 5/6, and I want to see if 1/3 fits in. Well, yes, it does. As a matter of fact, it would fit in twice. So yes, it fits. This is the first concept. So here, does 1/3 fit into 9/10? Yes. Does 8/9 fit into 2/5? Nope, it doesn't. Nope. Does 1/5 fit into 3/4? Yep, fits in quite a bit. And lastly, does 2/3 fit into 1/4? No, it doesn't. It doesn't fit. That's the very first thought with division. Is it going to fit? Yes or no. Once you have that idea, you're looking at how often it fits. Okay, so let's look back at this problem. Does this fit in? No. It doesn't fit in, only part of it fits in. If only a part of it fits in, my answer is going to be a fraction. Only a bit fits in. My answer is going to be a fraction. Okay. All right, let's look at this next one. Will this fit in? Yes, it does fit in. 1/3 fits in. 1/3 fits in once. 1/3 fits in twice. And it looks like it fits in a half a time. It fits in 2.5 times. So if you look at this problem, and this is the big thing, I have 5/6 of a whole. That's a thing. I have 1/3 of a whole, and I want to see if it fits in. My answer is not 2.5 wholes. I don't magically have 2.5 wholes. I have 2.5 times. It is an idea of how many times. How many times does it fit in? 2.5 times. So I can't take 5/6 of $1 million, divide it by 1/3 of $1 million, and now have $2.5 million. That's not going to work. But I will know that that fits in there 2.5 times. Okay, so to teach this point, I'll often give a student a whole page of division problems, and I have them just note which one's bigger. This is the bigger fraction. This is the bigger fraction. Bigger, 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 bigger. Will that fit in? No, it's bigger. Will that fit in? Yes. Will 1/3 fit in? Yes, because the first one is bigger. Will that fit in? No, because the second one is bigger. Will that fit in? Yes. Will that fit in? No. We're not even doing math yet. We're just seeing how the answer makes sense. That it fits in even a certain number of times means I'm going to have an actual number for an answer, a whole number. It's going to be like 2.5. And if it doesn't fit in, it's only going to be a part of it that fits in. So my answer would be 4/9. That's a part. All right, great. Next thought. Let's make this applicable to word problems. So here I'm going to have an answer that yes, it does fit in because this is the bigger number, and no, this one won't fit in because this is the bigger number won't fit in the smaller number. All right, I have $500,000 and I want to buy a boat which costs $250,000. Can I buy it? And one point is I always use examples that are really easy to picture. Everyone can picture that, yes, I can buy this boat, because you don't teach math with something you can't visualize. You teach it on simple problems you can visualize. So, can I buy this boat? Yes, I can buy this boat. It fits in perfectly. As a matter of fact, I can buy 2 of them. So there's an example of how that can be used. Now I've got a not fit problem. I have $250,000 and I want to buy a boat which costs $500,000. Well, I'm out of luck. I can't buy it. It doesn't fit. But the question then is, how much of it can I buy? Well, it looks like I can get half of it and then I run out of money. So I can buy half of it. How many times does it fit in? Only half of it fits in. Here's another example. I have 2/3 of a tank of gas and it takes me 1/6 of a tank to make a trip. Can I make the trip? Well, yes, it fits in nicely. As a matter of fact, it looks like I can make this trip 4 times. 4 times. Because this is the bigger number. Now I have 1/6 of a tank of gas and it takes me 2/3 of a tank to make a trip. Can I make the trip? Well, you can already tell I'm not going to be able to make the trip. Not going to make the trip. It's not going to fit in. But now the question is, how far do I get? I'm going to get this far and then I'm going to run out of gas. And that is 1/4 of the way. I'm going to get 1/4 of the way and then I'm going to run out of gas. So I hope this gives you an overview of how the math works and how it can be applied to actual word problems. The only thing from here on out is that the numbers get more complicated and it gets a little harder to draw, but these basic ideas won't change, and I hope this helps.